Hello, hi everyone. I'm Moose, um, and I'm happy to be here with you. So right now, hold on, let me just get this going. Cool. Looks like we're online, streaming. So I'm just gonna start with like just a short 1 minute meditation just to kind of arrive here with you. Light a candle, do that, and then we can do some hardware hacking. Well, we'll be doing simulated hardware hacking. Um, because I'm trying to write a custom chip with Verilog somehow. We'll see how it goes. Okay, first let's light a candle. Cool. Alright, and then we set a timer for 1 minute and be right back. And I'll be right here. Alright, just long enough. Okay, so, um, so previously, this, we were playing around with, oh, so previously, oh, we're gonna zero it. So previously we were playing around with this piece of Verilog code, which is mostly code we just picked up. But we used ChatGPT to kind of modify it to be able to draw the circle. Um, and then every time this bit switches, goes from 0 to 1. What's that? What's the code? Hmm, weird. Okay. I don't know what the code business is. Yeah, maybe it came from copy paste. There's some like copy link and code at the same time magic that um, VS Code had. I mean, Arc had. Oh, my camera's on. Alright, let me fix that. Oh, it's unplugged. That makes sense. A scanner. Da-da-dum, da-da-da-dum-dum. Okay. Do, 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 do. Okay. Alright, you're up. Okay, because you can see me, you can see this. Cool. Alright. So what next? Wire sound. Mm, we can do. Okay, sound signal is not driven or used. Oh, it just means it's unused, right? Shouldn't this work? Weird. Okay, so so I was looking at some Discord threads trying to figure out um this is pretty good. Discord anonymizing folks. All right, on how people are doing like analog stuff. Hi, listen, I need your help, please. In common mode, rejection ratio. Cool. Hmm, high Z fluid. All right, see what people are saying. How much time do we have left? 10 days. Cool. Interesting. Okay. I think we'll be doing HDL.
tab at the top here. We have 3 actions, one for documentation that shows how your documentation will look when it's printed, another will be used for automatic testing of walkway designs if you've used the truth table option, and finally we have the GDS action, which is used to build the ASIC files for manufacturing. If you want to find out more about that, we have a separate video showing how it works. It's called How the GitHub action creates the ASIC files. Let's take a quick look at the docs action. This is useful to see how your documentation will be formatted for the online and print datasheet. We get a PDF file we can download and check to see if the formatting and the picture works. Let's take a look at the GDS action results. We have this nice page with some warnings, utilization statistics, and standard cell usage. If you don't understand a warning, join us on the Discord chat server and post in the GitHub Actions channel. You can take a look at the cells in use by clicking these links. For example, this XNOR2 gate. Let's take a closer look at the 3D viewer. Right click to pan, left click to change the perspective, scroll wheel to zoom in and out. On the right we can see which cells are used and how many. Above we have the control for layer visibility. We also have some shortcut keys on the right. Pressing 1 hides all the filler cells, 2 hides the wiring, and 3 isolates the currently selected cell. I'd really appreciate it if you took a screenshot of your design and post it on social media with a description of what it does along with a Tiny Tapeout hashtag. Back on the front page of the repository you'll see we have these 3 green lights now for the docs, test and GDS all passing. The GDS status needs to be green to submit your design. Sometimes the GDS action will fail. A walkway design should almost always work. If not, then it's probably our problem and you should let us know in the walkway channel of the Discord chat server. If you're using an HDL, it's usually because of an error in your design or because the design is too large. To get more details, you can look at the logs here in the action results or download the zipped GDS logs artifact and take a look inside. First, check the synthesis log file under runs, walkway, logs, synthesis errors.errors for design errors. If your design is too large, then the failure will normally be to do with the placement or routing part of the flow. You can try to reduce your design size or upgrade to a larger design by increasing the number of tiles in your info.yaml config. When you're ready to submit, go to tinytapeout.com and then scroll down to the submission section. Click the button to go to our submission app. Sign in with your GitHub account, then copy and paste the URL of your GitHub repository into the form and press submit. If you have a coupon, you can apply it here, otherwise you'll need to pay to continue. At this point, you've created your project, but it's not yet part of the tapeout. You have to submit a revision first. Once that's happened, that version of your design is committed to the shuttle. If you want to make any changes, you need to come back here and submit a new revision. So that's it. Happy hacking, and I look forward to seeing what you make on your ASIC.
Cool. All right. So we're not gonna do while key Verilegs. Let's bring start for. Hmm. Hmm. Man, I am really at my desk. Interesting. Do-do-do-do-do-do-do. Hmm. Do-do-do.